All right, now we're going to talk about the tangent graph. So I did tangent separately from sine and cosine because sine and cosine behave very similarly, whereas tangent doesn't. So let's talk about some basic tangent facts. Um, if you notice, and you did the assignment yesterday, you'll see that tangent has a bunch of vertical asymptotes. So let's see exactly where these vertical asymptotes are located. I would say that I see the first vertical asymptote. I'm sorry, the first positive vertical asymptote at x equals pi divided by 2. Okay, and I see another one at x equals let's say 3 pi divided by 2. And I'm going to change that color because that's too much green. Let's make it red because that's what will make all vertical asymptotes. And then I see another one at x equals 5 pi divided by 2. Interesting. So, out of the 3 vertical asymptotes that I've so far highlighted, what do you notice that they all have in common? So I would say pause the video, think about the 3 values, and just what do they all have in common? Okay. They all have pi's over 2's. Now let's take a look at the numerators. Technically, for the first one, I can think about that as a 1 pi divided by 2, then a 3, then a 5. And so I would say that as long as I have odd an odd integer in my numerator, as long as it has an odd number pi divided by 2, I would expect a vertical asymptote for my tangent function. So here's how I have to express my domain then. Because this graph was just going to keep doing the same thing over and over and over again for all eternity. So my domain, I would, this time rather than use interval notation because there's a lot of exclusions I have to make, I would say all real numbers except n pi divided by 2 where n is an odd integer. And there are other ways to express that thought. I could make a little algebraic equation to guarantee that I always get an odd number. So if you have a callback to your integrated 3 days where you guys did the reasoning and proof unit, you'll note that I could write 2n plus 1. And if I replace that n with the 2n plus 1, I can kind of cut down some of the writing I have to do. Two n plus 1 pi over 2. And I can just say where n is an integer, right? You put in any integer value into 2n plus 1, evaluate it, you will get an odd number. Always going to play out that way. All right. The range, though, gets a little interesting because the range is dealing with the y values, and I got vertical asymptotes. And I note this. My graph goes here, And then it goes there. So the range is actually infinite. From negative infinity to positive infinity. Any possible number you can think of, tangent will equal that number. And if you don't believe me, when we get to a little further, you'll be able to test it out in a little bit. Okay, so we have that. We have the domain. We have the range. We haven't talked about the y-intercept yet. So the y-intercept is right there at 0, 0. All right. So now we need to talk about the period of this graph. So if you note, remember the period is the span of time, how often this graph will repeat its behavior. And the way I see it is it goes from negative infinity all the way to positive infinity. It goes from negative infinity, negative infinity, all the way to positive infinity. It goes from the negative infinity all the way to positive infinity. Nice tracing. And that happens every, let's see, it goes from pi over 2 to 3 pi over 2. It happens every pi units. So I'm going to go ahead and get rid of this, some of this stuff, so I can kind of try to clean this up a little bit. The period of a tangent graph is unlike the period of a sine or cosine graph. Instead of the period being 2 pi, the period is just pi now. That's how often this graph repeats itself, repeats its behavior. Pi units of quote-unquote time. Okay, so those are the 4 basic facts you should keep in mind when we talk about a tangent graph. The asymptotes, as of now, as far as we know, occur at odd integers of pi. The range is infinite. The y-intercept is 0, 0, and the period is pi, so it repeats after pi iteration, after a change in pi for your inputs. So let's go ahead and take a look at its transformations. So the first one we always want to start with is the a term. So here's what happens when a changes. Whoa. Okay. Cool. So I'm going to zoom out a little bit so you guys can kind of see that a little better. Right. Essentially what's happening is that the graph is stretching itself out vertically as the a values increase. All right. And if you don't believe me, then you can make this on your own and you can play around with it. I'm going to go back to the home screen. Cool. Now let's talk about the b value and hold on to your hats. Right? If we take a look at this now, typically what would happen is we would have vertical asymptotes at x equals pi over 2 and x would equal negative pi divided by 2. But let's change that to red so we can kind of match it. Okay. So within that span of time, if we look at the green, that's the tangent. That's the traditional tangent graph. It would complete one cycle. But now, when my b value is 2, look at what's happening. The tangent is starting at halfway through its cycle. It asymptotes out. It starts and completes a new cycle, and then it completes another half cycle. So rather than completing one cycle in the span of pi, it's now completing 2 cycles in the span of pi. Right? If we make this 3 instead of 2, it has 1, 2, 3 cycles completed in that same amount of time. So think about what's happening to the period of each cycle of pi based off that b value. All right? And just like we were doing before, we're going to bring this back to its stationary position at b equals 1. Right? So now let's see what happens when we mess with c. So if I let it play, it looks like it's moving up or down, but it's like, or moving diagonally, but it's really not. Actually, let me slow down. I would say keep your eye on the x-intercepts and look at how the x-intercepts are changing to help you kind of see it a little better, right? Here, then it goes there, now it keeps going over there, now it would keep moving over here, now it moves over there. So that's what's happening. The C value is just moving the graph left or right. It's not moving it diagonally. If we look at the D value, and again, just how we are looking at the x-intercepts, when we're looking at C, we're now going to look at the y-intercept when we're looking at D. So 0, 0, down, 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 up, 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 up. That's all the D value does. So it's a lot to take in. On tomorrow's assignment, we're just going to hopefully test how well you understand how to read the transformations and apply them. And I promise you all this will come back to solving trig equations, which is what you were doing last week towards the end of the week. All right? Take care.